Starting our day, we have a keynote speaker named Cornelia Davis. Cornelia is a technology fellow at Spectro Cloud. Previously worked in bringing to market Cloud Foundry, both the open source and pivotal CF project. Spent some time working on Kubernetes-based platforms, and she's the author of Cloud Native Patterns, Designing Change Tolerant Software. So, without further ado, let's start our day with talks. Cornelia Davis.
So I'm going to talk about Kubernetes and infrastructure, but maybe a little bit differently than you might be thinking. My hope is that I'm going to introduce several of you, or most of you, to a couple of projects. They're all open source projects, and we'll get into that right away. But before we actually drill into those projects, let me talk about Kubernetes 101. What we have here is a manifest. Yeah, right? In this manifest, I have a deployment and I have a service. So I have some microservice that I want to stand up. All right, so Kubernetes manifest. How does Kubernetes work? Well, we are going to store that manifest in etcd. Technically, we go through the API server, so we're actually making an API call. But what happens is that manifest gets stored in etcd, and then we have controllers, and those controllers are in the business of reconciling things into a runtime environment. And you can see that I'm being really generic here, and you'll see why as we go through the rest of the presentation. Now, in this particular case, when I'm doing just basic containers, what am I going to reconcile into there? Well, most likely onto worker nodes, could be onto control plane nodes as well, but most likely I'm going to be orchestrating some pods. So those controllers are going to be in the business of getting those pods out and running on Kubernetes and making sure that they stay running. But notice that it's not only, in most cases, it's not only orchestrating things into Kubernetes worker nodes, but it's usually orchestrating things onto infrastructure. So for example, if you have a load balancer, it's going to provision, if you're, let's say you're running on AWS, it's going to provision an elastic load balancer. So that's what the controller does. And I wanted to start with this because I'm going to keep coming back to this pattern. And I recognize that most of you probably know this, but again, I'm going to come back to this pattern. So, why did I start there? We're going to be talking about that Kubernetes pattern applied to infrastructure. I'll tell you in just a moment what type of infrastructure I'm applying it to. I hope that you'll find it kind of interesting the order that I'm going to go into these. A little bit more about me. Matt already said, but I have been doing containers for longer than Docker has even been around. So I was in the early days of Cloud Foundry. We were orchestrating containers. We were creating container images. They were not Docker images. Docker didn't exist then. So I've been doing this kind of eventually consistent thing that I just showed you in the previous slide for more than 10 years. In the later days of my time at Pivotal, I did get involved in Kubernetes. So I think I've been doing Kubernetes, I don't know, since about 2017 or so. I worked on a project called Pimple Container Service together with VMware that we brought to market as well. I've also, of course, been doing microservices and that type of stuff for a long time, and there's a picture of the cover of the book that Matt mentioned that I wrote. So that Kubernetes API pattern looks like this. We have a declaration of some state. We have the desired state as it's stored in the Kubernetes environment, so in etcd. I have an actual state that's running in some environment, some runtime environment, and that controller is in the business of reconciling the state between the actual and the desired state. And I like to call this actually the implementation of the API. So the API is actually a very declarative state, but this is the implementation. So if we take a look back at container orchestration, there's one thing that I want to draw your attention to, which is that controller. Where is that controller running? Well, that controller that is implementing that controller, it's right down inside of here. It's actually not running as a container because, in fact, it's the thing that is orchestrating all of those containers. So we have a bit of this bootstrap problem, right? So we need to get started with something. So this is else can I apply that to? Well, it turns out that years ago, maybe 3 or 4 years ago, or maybe even as recently as 3 years ago, this notion of controllers applied to all sorts of other abstractions was still relatively new. I think most people thought of Kubernetes as a container orchestration system, and that's it. We thought about containers, and we thought, well, if I'm going to get things on Kubernetes, I have to containerize things. Well, it turns out that I like to think of that as just use case one for Kubernetes. Kubernetes has a beautifully extensible API, and we can apply this pattern to all sorts of things. 3 years ago, that was pretty uncommon. These days, there's controllers that have been built for tons and tons of things. So the ones that I want to talk about today, I'm going to talk about 3 different projects. I'm going to focus on infrastructure projects. So the first thing that I'm going to talk about is virtual clusters. Who knows what a virtual cluster is? Okay, a handful of you. I figured most of you wouldn't, so I'm going to explain them. So this is not a virtual cluster. This is a standard Kubernetes cluster. I've got a host cluster there. And if I want to run different workloads on there, or let's say I want different tenants on there, the main abstraction that comes in Kubernetes to separate these things is the notion of a namespace, right? You're all familiar with namespaces. Well, it looks in this picture like these things are pretty separate, but you've probably heard that namespaces don't give you the type of isolation that you might need in certain settings, especially in regulatory or very secure environments. Because what really happens is that we have shared resources that despite these different namespaces, I still share some resources. One of those shared resources that I want to draw your attention to here is the API server. So the API server, despite the fact that I have these multiple namespaces, the API server is shared. So each one of these individual users, individual tenants, we're all going through the same API server. We're also using some of the same networking, and there's a whole bunch of other shared resources. Here's what a virtual cluster is. And I should be very clear here that when I talk about virtual clusters here, I'm talking about an open source project called vCluster. So vCluster does the following. It effectively runs an API server inside of each of the namespaces. And I'll show you a command line screen in just a moment to show you how that's all broken out. But it runs an API server inside of each of the namespaces. So now you can see that each one of these users have their own API server. That's important, even if you're only doing this in a dev and test environment. And by the way, vCluster is being used in production in a bunch of different settings. So they found that the security posture of vCluster is sufficient to run these things in production. But what they're doing is, again, now each one of these tenants has their own API server, which means even in a dev and test environment, each one of those individuals can install cluster-wide resources. So for example, if you are building the very controllers that we're talking about here, you're creating new custom resources, those things are installed at the cluster level. So now you can do this in a dev and test environment where you're installing custom resources, not cluster-wide, but you're installing them in each namespace. So you can see here that we're starting to strengthen our isolation with vCluster. The other thing that vCluster does is it starts to apply policies at each one of those namespaces. There's a number of different levels that you can apply it, from totally insecure, where each of the namespaces can still see each other and look inside of each other, to an isolation mode, where it's applied all of the controls and policies at each one of the namespace levels so that you get a reasonably strong security profile. I'll tell you what I mean by reasonably strong in just a moment. Now, and in fact, here it is. Here's the slide. So this slide comes from the vCluster GitHub repository. And what you can see there is that they don't claim to have very strong isolation like separate clusters do, but it's far stronger than the weak isolation that you get out of the box with namespaces. namespaces. Out-of-the-box namespaces are not that secure. But what they've done in vCluster is that they have specific modes that apply policies that are already vetted that give you this strong isolation that you see in the middle here. Now, very, very briefly here, vCluster is super clever. What it does is it runs that API server inside of the namespace, and it keeps things in that API server higher level abstractions, like the deployment. That's something that is just kept up in etcd. The deployment itself doesn't have a first-class entity running as a container. It's just an abstraction that exists in Kubernetes. When it comes down to the containers, those containers are in fact running in those namespaces on the host cluster. And it does this via this syncing process. Super clever project. And like I said, it works extremely well and is being used in production. Now, how does this apply back to the pattern? Remember, this is our core pattern here. I've got my manifest that describes these virtual clusters, and I've got a controller, and it's got attributes like how many Kubernetes, how many nodes do I want, what version of Kubernetes am I running, and so on. What's the runtime environment that I'm targeting with this controller? Well, it's Kubernetes itself. So I'm starting with the Kubernetes environment, and I'm adding to it this vCluster capability. So this controller is actually running inside of that Kubernetes cluster. So the pattern is the same, but I wanted to show you where that controller is running. Now you can see the little loop on the right-hand side there that shows that what is it that I'm orchestrating? Well, I'm orchestrating these namespaces, and I'm orchestrating the Kubernetes API and some of those core, what have been shared core services for Kubernetes. Those are getting run inside of the namespace. So here's what it looks like. If I've just gone and I've said, okay, let me see what's going on in the pods in my host cluster, what you can see here in all caps is that you can see that the controller manager, that's the actual controller. That's the controller bubble that I showed you in the very top. And then all the things that it is orchestrating are the things that are in bold in the lower part. There is the cap VC, so this is Kubernetes cluster API, which I'm going to talk about in just a moment. So I've got a cluster API controller that's managing that API server inside of my cluster. I've got the Kubernetes controllers. Remember the one that was running as a process? Well, that's running as a process inside of one of these containers. And then there's some of these other core services like core DNS. Okay? So you can see here that we have these controllers. We're using Kubernetes to manage virtual clusters, virtual Kubernetes clusters. All right, and I say that, hey, those virtual clusters, they're infrastructure. So what other kind of infrastructure? Well, I'm going to talk about virtual machines. So let's go back to our picture here, and let's get rid of those namespaces and look at a different element of that host cluster. In general, those host clusters are most often being run on infrastructure as a service. So whether you're using GKE, or you're using K8s, or you're using EKS, or you're even using it on any one of those, any other providers, or you're doing it on top of VMware, usually you're running those clusters and you're creating the various nodes on top of infrastructure as a service. Now that infrastructure as a service is running Kubernetes, and maybe it's running some other virtual machine workloads, but you're using a different management plane to manage those virtual machine workloads. Now, I'm going to suggest that what if instead of, and of course it's orchestrating these pods, what if instead of going on infrastructure as a service, I go on bare metal? So I've got my cluster running on bare metal. So let's start with that. Cluster's running on bare metal, and I can be running all of these containerized workloads. my virtual machine workloads inside of that container. And the way that I do this is that I have a manifest that describes my virtual machine. So now I'm using the same API pattern to manage my virtual machines as I do to manage my containers and my virtual clusters. It allows me to have a single kind of operational paradigm across all of these different things. Now, the way that vCluster works is that it leverages the Kubernetes abstractions. Because remember, Kubernetes itself is infrastructure, and it has abstractions for going down to the compute, and it has abstractions for going down to the storage, and it has abstractions for going down to networking. That's where you're using your CSI and your CNI for those latter two. So what KubeVirt does is it leverages those Kubernetes abstractions to bridge the gap between your virtual machines down to the actual hardware resources that are needed for it. Super, super slick. So what does it look like from this perspective? It's, of course, it's running as a bunch of controllers. So this is one of those extensions to Kubernetes. But again, we're starting with Kubernetes, which means I can run the controller inside of my cluster. And now I've got this little control loop that is managing things inside of the cluster that this controller is running in. What's it managing? It's managing the things that I just talked about. It's managing the pods for compute, and it's managing those Kubernetes abstractions that are there for storage and networking. So all of those abstractions it's managing there. So quick screenshot here, what you see is that there's two different parts. In the top, what I've looked for and I've bolded is I've showed you the controller. That's the controller that's running in the upper right-hand corner, that bubble that's controlling the virtual machines. And then what you see down below was I just did a quick view of the virtual machines that I have running in my cluster. So each one of those bolded things at the bottom is a pod that is running a hypervisor with a virtual machine inside. Okay? So that's the way KubeVirt works. Basic Kubernetes pattern. All right. Oh, and by the way, it's not just a single controller, it's a whole series of controllers. Just like Kubernetes has a controller for deployments, which creates replica sets, and then there's a controller for replica sets, which create pods, and there's a controller for pods. These are all the controllers for KubeVirt. It's a pretty sophisticated project, as you can imagine, because it's running virtual machines. All right, I'm going to go through my last one here, which is, okay, I've talked about once we have these Kubernetes clusters, which I'm saying are infrastructure, I can do all sorts of interesting infrastructure things on top of those Kubernetes clusters. Of course, how do I start with the clusters themselves? Well, it's this same basic pattern. There's a project in the CNCF called Cluster API. What Cluster API is in the business of doing is applying the same pattern to the creation and management of clusters themselves. Now, in this particular slide, I want you to recognize that on the far right-hand side in the runtime environments box, it doesn't say Kubernetes, because I don't have Kubernetes yet. I'm trying to create Kubernetes. So what I have on the right-hand side is I just have infrastructure. I have my cloud, or I have my VMware, or I have my bare metal. And now I want to bootstrap that with a Kubernetes cluster. I have a controller. That controller knows how to do things like create nodes, create control plane nodes, create worker nodes. And that's exactly what it does, is it creates these control plane nodes and creates worker nodes. But wait a minute, those controllers, don't they usually run on Kubernetes? And technically they don't have to, they're just processes. But usually they're running on Kubernetes. And so we need a Kubernetes environment to run these controllers. And the way that this generally works is that we have a bootstrapping Kubernetes environment that is running that controller, that has the credentials to talk to the infrastructure on the right-hand side, And then those controllers start provisioning and then managing those the nodes for the cluster. But here's the thing. Once we have the Kubernetes cluster on the right-hand side, we can do something super clever. Remember, there's a Kubernetes cluster over there right now that has an etcd. We do what's called a pivot. And we move everything from that bootstrapping cluster into the cluster itself, which allows us to then get rid of the controller on the bootstrapping cluster, and now the cluster is managing itself. So that, again, is another one of those things. Last screenshot here, again, you can see that there's a whole bunch of controllers, the CAPI and the CAPA controllers, and you can see the different components that are running in there. My last slide that I just wanted to show you is all of these things together. I've shown you containers, virtual clusters, virtual machines, and clusters themselves. They're each open source projects that I have listed here on the right-hand side. They each have their own control planes, if you will. They each have their own CLIs. So there's a bit of complexity involved in there. But I encourage you to take a look at these projects because it is allowing you to now take not just your containerized applications, but all sorts of other things and all sorts of other workflows and leverage Kubernetes to run those, develop those, and manage those. And with that, I thank you for your attention. I apologize, I probably went over by a little bit, but not too bad. And also, I'm going to be around. I'm going to be at the event this evening as well, but I'll be around all day, and I look forward to chatting with many of you. Thanks so much.